Hello, my name is Cantu. Welcome to this CodeRage Mobile session about the Delphi language for mobile development, focused on the change to the Delphi language for the iOS compiler that was recently introduced in Delphi XE4. I'm Marco Cantu, used to be a books author, trainer and consultant around Delphi. I'm currently working for Embarcadero Technologies as Delphi product manager. Here you can see my contact information. That hasn't changed much, but of course there is a new email address to get in touch. So the focus of this session is Delphi new compiler, or as we call it internally, NextGen, next generation compiler. It's not just a compiler for a new platform, the ARM platform, but it is actually a compiler based on a new compiler architecture. I mean, new for Delphi, of course. The compiler is based on LLVM, which is a compiler architecture. It's an open compiler architecture, also used by Apple in Xcode. It supports multiple backends, one of which, and the one we are currently supporting, is the ARM backend focused on iOS support. Of course, the same ARM backend will also be used in the future to build Android native executables. So the important thing to keep in mind is that we are talking about this next generation compiler, but actually Delphi XE4 ships with two different compiler architectures. The Win3264 Mac iOS emulator compilers are all based on the classic architecture. Although the iOS emulator compiler shares a number of features, including ARC, the new memory management, with the NextGen compiler. And then for iOS today and Android when available, we are using the NextGen, the LLVM architecture. So what are the compiler changes? And before even we get to that, why is there any compiler change? There is certainly a push to optimize the way you write code for mobile. Memory considerations and CPU are actually less powerful on mobile, so optimizations is relevant, but that hasn't been actually the driving force behind some of the compiler change. There is also, and on top of it, the need to simplify the language, to improve the language, to clean up the language. Some of these changes are actually meant for new developers, but ultimately every Delphi developer will benefit from a cleaner architecture. There have been honestly also some language quirks and strange behaviors that we're also trying to clean up a little bit. So in practice, the effect has been a significant cleanup on the string types. There are like countless string types on the Win32 compiler, some of which would make completely no sense. But we got a little bit to the extreme of removing all secondary string type and just keeping string, which is represent Unicode strings. But the other change, which is the most relevant change, and the most relevant new feature, is reference counting based on automatic reference counting model. More or less like it happens with strings since Delphi 2 and with interfaces since Delphi 3. We have extended reference counted model that lets you automatically manage memory to all objects. This is not like having a garbage collector, but it's a different step in the same direction of simplifying memory management and reducing the work that a developer has to do to make sure memory is managed properly and there are no leaks. So getting back to string types, as I was mentioning, there's one string type, and it is Unicode based, so it uses 2 bytes per element. You can use record types to represent 1 byte strings, or you can use T bytes I mean arrays of 1 byte elements. But by default, the product only ships with a single string type. The other change, which is just an option you can reconfigure with a compiler directive, is how the open and close square bracket is treated by the compiler. By default, we have switched only for the ARM compiler, only for the mobile compiler, to zero-based access, which is what is used by each and every other language in the world, and also what is used in Delphi for every other data structure but strings. Honestly, this is not such a big deal, but you have certainly to have a look at your existing code, or decide to stay with the traditional and use that compiler directive. We are encouraging the use of t-string helper as a way to improve the code, but if we look at this code fragment that has code that depends on the position, you can see that when you're using chars, the t-string helper access to one individual element, that remains the same. This is zero-based regardless of your platform. If you're using accessing a position by number, this code will have by default a different effect depending if you are on mobile or on Win32. But again, something you can control by turning on directive, either one way or the other. All methods, from the new ones like indexOf to the traditional ones like pause, they remain exactly as they were. So there's no change at all for methods that require numeric position. But again, the focus is to move towards using the t-string helper methods that were introduced in XC3 and work the same across all platforms. And notice also that if you are accessing in a logical way to an element, because this is not the best readable and meaningful code overall. So if you're using a constant for accessing the position, you can define a constant in a way that the constant assumes the right value depending on the platform, for example using the low function. So this is still a constant, there's no runtime overhead at all, but it will be compiled in a way that it behaves properly on each platform. Similarly, when you are running a loop, you can write code like going from low to high to go through all elements of a string. You can also use a for each loop, actually for in as it's coded in Delphi, so for character in string. But if you want to stick with traditional for loop with a position, this is a way to go around this change and make sure your code works throughout all versions of Delphi and even on older versions of Delphi. Okay, that's what I wanted to show about strings, because I want to have a little time to focus on the other main issue, which is automatic reference counting, or ARC. Again, like strings interfaces have been for many years, object references are now managed. This means that if you just create an object and let it go in that end statement, the object will be destroyed when the end statement is reached. Actually, to be more precise, the object reference will be decreased, and given that, unless that code does something odd, that object reference will reach 0, then the object will be destroyed exactly at the end statement. Now, looking at it as it is, looks quite simple. It's not as simple. It implies understanding the model a little bit. There are a couple of key elements I want to mention, but let me show some code first. So here are some very simple code snippets. Again, you can just create and use an object. No need to destroy it explicitly. But if you have existing code with a try finally block, that code is going to work fine. There is no significant drawback. The statement myObject.free, which is standard on classic Delphi compilers, so it's still the default on Windows and other platforms, that code can be used also on the ARM platform. The compiler will automatically kind of remove that code. There's no function call anymore. The object will be just set to nil, so the reference count will be decreased and the object will optionally, and in this case quite certainly, be destroyed. You can even write free and nil of the object, although that's not the ideal code in most scenarios. So again, you can also write simply nil an object. Now this code won't make much sense on Win32, will most likely cause a memory leak because you're not freeing the object, you're just setting the reference to nil. So if you want to have code that is portable among the two platforms, keeping around calls to free is actually a suggested option. Again, there is more than that. There is the ability to call dispose of for immediate destruction. Dispose of will execute the destructor code even if there are still pending references, but that's something that should be used in extremely rare scenarios. It's not a standard coding practice. Again, the standard coding practice is just letting an object go, setting it to nil, or calling free if you need backwards compatibility. The other thing, when you have multiple objects that reference each other, you can use weak references, just prefix the reference with the weak attribute. When using a weak reference, that reference is still a valid reference, a valid pointer, but it will not increase the reference count. So it doesn't count as the number of references that keep an object alive. And the implication is that object might be destroyed, but weak references are managed. So if you can actually query a weak reference to know if it is still valid, and if not, you can realize that all strong references to that object were gone, and so the object has been destroyed. Of course, there is much more to that, but that's what I can cover in this short amount of time. Operators overloading is a new feature that's been added because it does require ARC, it does require automatic memory management for temporary objects. In the past, it was available only for records. Now, operators overloading is available also for classes. So this is a very simple class that has an add operator. The add operator returns a new object. This is important. These are not operations that modify an existing object, but what they do is they create a new object and return it. So you need to do tNumber.create, otherwise you get an access violation. And then you can do whatever internal operation. The strange thing, of course, is not much this code, but the calling code, because given this object, you can actually say C equals A plus B, where A, B, and C are actually objects and not of classes and not just records. You can find way more details, actually 40 pages of details, in a white paper that I wrote. It's called Delphi Language for Mobile Development. It also has suggestions for keeping the same code under both Win32 and mobile. So that's it. There should be some time for questions. After that time is over, or if you're seeing this as a recording, feel free to send me email or comment on my blog. Thanks. Goodbye.
Bruce was asking about when do you think, and it's always that when question, the new language features might show up in the rest of the compilers?
Yeah, the problem with the specifically with Arc is that the Arc does not require the new LLVM compiler. In fact, we have Arc enabled on the traditional Intel compiler for the Mac simulator today, in XE4. We are certainly interested in aligning the features and make sure that we also have the same behavior available for other platforms, notably Mac itself and Windows. The real issue is that while the RTL and FireMonkey are written in a way that they are really independent on the model, and we should try to leverage Arc. If we decide that the Win32 compiler has Arc support built into, that means that all of the existing BCL code will have to be reviewed and checked, which is something we certainly don't want to do. So ultimately, it's difficult, and it's the alternative. Of course, will be to make both options available, but that's far from trivial because it means having two versions of the runtime library for Win32, Win64, and Mac to be tested and developed in parallel. And that's a huge effort. So we are considering options. We certainly want to expand the platforms for Arc, but there are some significant issues going forward.
And Thomas is asking again about calling create and calling free and what happens. So maybe just a quick summary again about
the
free and then dispose of.
Yeah, the most important thing is about the advantage of mixing objects with interfaces. In the past, it was really unadvisable to mix objects and interfaces on traditional Win32 compiler because they use different memory models. So you could easily have an object that was destroyed behind the scenes because there was a temporary interface pointing to it. Now with Arc, the object and the interface are just the same thing and use the same reference counting mechanism. So you can really mix interfaces and objects as much as you want, which is a great feature for the language. It's true that, on the other hand, the T-component model tends to work on a different approach. Now, there are some weak references already available in T-component, like the owner reference that goes back. There are several scenarios. One scenario that doesn't actually work properly is that what's common in Delphi is to have an object that is part of multiple different containers or multiple different lists. And then we traditionally relied on the model of freeing the object, and by itself, the object will remove itself from the containers. This is kind of goes against the ownership model, where it is the owner that should free the object. So if you remove the object from the main owner, then the object will free itself if the secondary references are weak references. So there is a way around it, but of course it implies using a different approach in writing code. And I'm actually having a discussion about this specific topic and want to actually be able to publish some blog entries about this. If you haven't seen it, actually there's a very nice and detailed blog entry by Alan Bauer. He wrote it last Friday, that covers some of the reasoning behind Arc and some of the issues that are still open around this model. The other thing I wanted to mention, again looking at the question, is these strings, the zero-based, one-based. Zero-based, a string is just a string. So whenever you look at it, you pass it around, the physical representation is the same. That's why we can just have a compiler setting, and we don't have to deploy a new runtime library or a new version of compiled code, because ultimately a string is just a string. It's just the way square bracket 3 is interpreted. This is the third or the fourth element in the string, and this is a local evaluation that's done by the compiler, and you can fine-tune it. Now, the difference that we have two different defaults, but you can have zero-based strings on Win32 if you want, starting from Delphi XE3, and you can still decide you want one-based strings in your code on iOS, because there is a compiler directive you can use to force one way or the other. Ultimately, our suggestion is to move away from the topic and just use the string helper methods, which are all zero-based in logic, regardless of the platform you're onto.
And in fact, all these helpers are also for record helpers and other things, right? It's not just for strings themselves. You can do.
Yeah, actually, one of the additions in XE4 that we kind of haven't really mentioned or pushed is that we have now helpers for integers, floating point numbers, and many other native data types, all of the numeric data types. So you can have your number to string rather than int to str. And of course, the good thing is that toString you can apply to almost any of the native type, to a Boolean, to an integer, to a floating point number, and the same mechanism works. You just enter your variable, dot, wait a second for the code inside. You get a list of the operations you can do on a native type, and that's very handy.
Yeah, people keep asking about more specifics on Android support, and right now we're just saying, JT said this year. Frank's going, it's not specific enough. Do you have a date? And I said, sorry, no, it's software, right?
Yeah, we hope to have a date, but until that hope becomes a reality, we actually not spread a date that might not end up being a real date. I mean, honestly, it's a new platform. It's very nice. We internally have code that works on that platform, but as far as shipping, it will take some more time.
It just takes time. And maybe you answered this already. I know every string is Unicode string since 2009. Can you still use ANSI strings on an iOS device?
No, you cannot use an ANSI string on an iOS device. You can use tbytes, which is a dynamic array of bytes that behaves very similarly to a 1-byte string or an ANSI string or a UTF-8 string. But of course, it's not as good because it's not like really compatible. There's been a couple of developers who have created helper records that embed the ANSI 1-byte strings. We have some internal code. We might release it as a demo or as potentially even as part of the core system. It's still under debate, but we're still really looking forward to ways to simplify moving code that's based on 1-byte strings also on iOS.
Oh, says Frank is saying strings on iOS are slow. Use tbytes.
Well, the problem is that it's very. I mean, there is a drawback in using Unicode strings on the platforms because Unicode strings means bigger strings and means bigger files. So for people that don't need Unicode is actually kind of counterproductive. But for the rest of the world, where Unicode is extremely significant because you can really live without the ability to use extended set of characters, we really have to focus on one model. And having different defaults for different platforms will be really very confusing. So I think the idea of having Unicode strings, UTF-16, 2 bytes per character, plus 4 bytes for the very odd scenarios where you're using the extended character set. I mean, that's a good model to use to our platforms.
Well, thank you, Marco.